So let's look at an example of applying the 68, 95, 99.7 rule, how we can find answers to some of these questions about where certain percents or proportions of the students fall using not having to use technology, okay, just using the rule and counting by standard deviations and the areas that go along with that, okay. So the distribution of Iowa Test Basic Skills, one of these standardized tests, but their vocabulary scores for 7th grade students in Gary, Indiana is close to normal. Suppose the distribution is, remember this is our notation, it's telling us, the end's telling me it's a normal distribution. The first number is the mean, so the mean is 6.84, and the second number is the standard deviation, 1.55. So the first part of this question, sketch the normal density curve for this distribution, and then we're going to answer a couple of questions about percents. But let's start with the sketch of the distribution. So we have a normal distribution, so we know that it's going to be bell-shaped. And you could just draw yourself a rough sketch of this if you're doing it by hand, but you have the best you can. You make a shape there, but I use the computer, so this one will be pretty precise. So we've got this nice bell shape, where in the middle I'm going to have mu. Okay, so that's 6.84, my average score, the mean score. And if I go one tick mark forward here, which gets me to that change of curvature point, that would be 6.84 plus the standard deviation, 1.55. So if you do 6.84 plus 1.55, that value would be 8.39. If I take 8.39 and I add another 1.55, I get 9.94. And I'm going to go ahead and go a little further. If I add another 1.55, I get 11.49. So I've gone 3 standard deviations since our rule goes up to 3 standard deviations out. I'm going to go above and below. Okay? So to go below, I take 6.84 and subtract 1.55, and I get 5.29. Subtract 1.55 from that, I get 3.74. And finally, subtract 1.55 from that, and I get 2.19. Okay? So to set up a normal distribution picture, especially with the rule, the 68, 95, 99.7 rule, where we're counting by standard deviations, draw yourself a bell curve with an axis under it here, and right in the middle you've got your mean, and then you add copies of the standard deviation and subtract copies of the standard deviation to label the axis there. Okay? So that's the first part of this question, sketch the normal density curve for this distribution. The second part says what percent of the Iowa Test of Basic Skills there, ITBS, vocabulary scores are less than 3.74. Okay? So I've animated in everything that we need to answer that question here, but that's 3.74. If you look at that, that's 2 standard deviations below the 6.84. So the first thing I would do is I would locate 3.74 here on the axis. And we want to know what percent of the scores are less than that, so I'm really looking for the area that this arrow is pointing to, which winds up being 2.5%. But we're trying to find the area below 3.74, to the left of 3.74 in the picture here. Okay? I always say above and below, for above being to the right, below to the left, but it's on the picture you're above the axis, below the graph, and to the left of 3.74. So that's the area we want. The rule tells me that if I go 2 standard deviations in each direction, we get 95%, but that leaves 2.5% out here in the tails. It's the 5% split. So if I want to know the percent that are less than 3.74, I would look for the area to the left of 3.74, which winds up being 2.5%. Okay. So often we need to know the value in the tails instead of the value in the middle. The rule tells me if I go 2 standard deviations in both directions, I'm going to get 95% in the middle, which leaves 2.5% in the tail. Okay. Sometimes we have them where it's mixed and not symmetric, as you'll see on this one. What percent of scores are between 5.29 and 9.94? Well, those are both values on my axis here. 5.29 is 1 standard deviation below the mean. 9.94 is 2 standard deviations above the mean. And there was the circle. The answer to the second part is 2.5%. Okay, I made a new animation for the third part here. So again, there's the area we're looking for. We want the area that's between 5.29 and 9.94 in the x direction, but then between the graph and the axis. Okay, so, and I've just drawn in the areas we're going to need to compute it here. And you can piece this together in a lot of different ways. I like to use the tails. Okay? We have, when we go 1 standard deviation out, there's 68% in the middle, 16% in the tail. So if we only go 1 standard deviation below the mean, there's 16% left in the tail. If we go 2 standard deviations above, there's 2.5% left in that tail. And what we can do then to find the area in the middle is just take 100% and subtract the 2 tails is the way that I did it. So we have 100% under the curve, minus 16% in the tail on the left, minus 2.5% in the tail on the right will give me 81.5%. So we can find any combination of counting by standard deviations above and below. We can use, if we go 1, 2, or 3 standard deviations above or below, we can use the 68, 95, 99.7 rule, as we call it, by the area that's between in the middle when you go 1, 2, and 3 standard deviations. So that's how we could do it if we were counting by standard deviations.